Hi, I'm Phil, and I'm continuing with my progress using the new Grove Vision AI version 2 kit. And the aim is that I want to develop a few projects. And the project that I'm planning is controlling traffic signals. So a Xiao computer, together with pulse width modulation, will switch on and switch off traffic lights. So the project hasn't started yet, but I'm building up the software in stages. And to do that, I'm looking at some unit tests. So I'm looking at a 4-digit display for giving pedestrians feedback on how much time they've got to cross the road. And I'm looking at the traffic signals. So let's have a look at the latest project in traffic signals. So we're doing pulse width modulation, and the pulse width modulation, the latest project is this one. So let's have a look at the desktop for doing that. Well, have a look at the overall project. And the objective is to get the Xiao ESP32C3 to switch on traffic signals. And I want to be able to expand that to a maximum of 16 traffic lights. So it's more than sufficient for a intersection. So the demo that I'm going to do here is going to have 2 sets, and each set will have red, yellow, and green. Later, we'll add the pedestrian timer. So that's the overall objective. And we'll just move that down. You can see my desktop arrangement. I'm using 2 sets of traffic lights. And we walk over, you can see it from the top, the Xiao computer sitting on a Grove carrier. And I'm using the Grove pulse width modulation, 16 channel, to switch on and switch off the lights. Okay, so let's have a look at the hardware that I'm using for all of this. So starting off with the Xiao computer, you can see what it looks like, and the Grove base for Xiao. And then we've got also, on all of these components come from Seed Studio. And I'm going to use the Grove pulse width modulation, and you can see the connections. So I don't even need the external connections, the external power supply. So I'm just using LED control, and I can get up to 16 channels doing that. Here are the cables that I'm using. And for my traffic signals, I'm using the Kitronics stop bit, which was originally designed for microbit, but I've adapted that for the Xiao computer. Alternatively, there is a set of traffic lights available from Key Studio, and here you can see that I've mounted these on the Fisher Techniques components. Okay, so later on I'll be using the Raspberry Pi, and I'm using plenty of Lego pieces, including the adapters and the baseboard. And for the connection, I'm going to rely on knowing what the functions of all the pins are. So that'll be an important aspect. And this is what it looks like. We might actually go across now and have a look at that. Okay, so if we look at the traffic signals, we start off with our Xiao ESP32, and we connect that via the USB to a Windows computer, and that's where we do all of our programming. And we can also report on the status of each phase of the traffic signals. We put the Xiao onto a Grove base for Xiao, and we have access to the I2C port. And that's where we connect a Grove hub And it allows us to add a couple of additional extensions using the I2C port. And the first one we're going to add is the pulse width modulation, where we can easily extend to a number of traffic signals. And I'm only going to show one. So here's the Kitronics and the connections to normally the servo port. So you can see that I've got control of one set of traffic lights here. And this is what our next project will look like. So we'll have traffic lights, and I'll be adding a second set along here, and I'll be adding a second I2C controller, and that's going to be the Grove Vision controller with a camera, and that will be used to give pedestrian priority. So the more pedestrians that come along, the shorter time that they'll have to wait to switch in the lights on. And I'll be adding a 7-segment pedestrian countdown timer to let the pedestrians know. Okay, so that's the project extension, which I'll show on my next video. Here we have the Xiao computer-controlled traffic signals. And it's all based on a small computer called the Xiao computer. It's an ESP32 C3, and it's on a carrier. So we put the Xiao computer onto the carrier, and here's the carrier. And the carrier is connected to a I2C device, which would normally control servos, but in this case it's controlling LEDs. And I had a bit of trouble trying to get simple LEDs to work, and the ESP wasn't very good at providing many ports. But with the Grove servo, or the pulse width modulation board, I can get up to 16 lights, so at least enough for a set of traffic lights on an intersection. And this is a unit test, and we're going to add pedestrian vision control to that later. Now I'm using the Kitronic stop bit, which was originally designed for microbit, and it goes on an assembly like this with microbit. Alternatively, you could use the TE Studio, and this fits quite nicely with the Fisher Technique components. So that's an alternative that you could use. And another project that also uses a Kitronic arrangement is streetlights. And we can get the Xiao to, instead of using the microbit, so we've got a microbit here, instead of using that, we could use the Xiao computer, and it has a light sensor on board. Now, in the future project, we're going to add the pedestrian control. So when a pedestrian comes, it will give the pedestrian priority at the traffic signals.